So the main concept in this chapter is related to the timeline of the waves, or the timeline for the frequency and the wavelength of the waves. And next, we have seven different waves, and we also discuss about the name of seven different waves. And then we start talking about their individual properties and their uses in our daily life, right?
Yes, sir.
Okay. So we end up with three waves: radio waves, microwaves, infrared waves, and we also discussed that what is the difference between radio waves, microwaves, because both are like the same, but only there is a difference that microwaves can only be used for transmission with satellites, and radio waves can only be used for the local transmission on Earth's surface, right? So that is the only difference between these two waves, because both are like used for the same purpose for communication, but the communication medium is different from each other.
What's the difference, though? I'm confused.
Okay, so let's suppose if we talk about the radio waves. So in our daily life, let's suppose we are connecting via Zoom app, right? So basically, when we connect local on the ground level, right? So on the ground level, let's suppose, so if you want to connect one phone with the other phone, or if you try to call dial any specific number. So those signals from the towers, right? You observe the towers of signals that are used for the telephone and that are used for internet connection and the TV station. So all these signals are actually works on radio waves, right? And let's suppose if you want to directly communicate with the satellite, it means that the higher organization or the institute or the organizations that are actually managing the whole data. So actually those organizations and those institutes are actually connected with the satellite, right? So radio waves are longest in the wavelength, and microwaves are shorter in wavelength as compared to radio waves, right? So that is the difference. Okay.
Basically, infrared rays are the longest ones.
No, no, radio waves, according to the
Radio
table.
waves.
Yes, according to the table, the left hand side, the radio wave is the longest one. This is the longest one, and gamma rays is the shortest one, right? In the wavelength,
Oh,
right? So you need to remember this timeline, because that is very much important. Okay, so let's continue with the new type. And the third type of wave we need to discuss is our daily life, visible light. Okay, visible light is actually a part of a spectrum that can be visible with our normal human eye, right? Other waves are not visible with human eye, but this visible light is actually easy to observe with human eye, right? So visible light actually consists of seven colors, consists of seven colors, and can be observed by human eye, right? Because the daily life of white light is actually the use of the visible light, right? There is no such specific use that we specially used in our daily life. We know that to reflect the light or to refract the light or to observe the object, and different optical applications are actually based on the light section or the visible light, because we already have a detailed chapter of light. So that's why we are not going to discuss this topic in very much detail over here, because there is a complete whole chapter of light. Okay. And if we talk about the human eye, so human eye can detect Range of wavelength, 750 nanometers to 380 nanometer. Nanometer means 750 into 10 to the power minus 9. So this is the wavelength for the maximum range that we can observe from our normal human eye, and the 380 is the lowest value. So this 750 nanometer is actually the range of infrared, and this 380
Okay.
nanometer is the range of violet light. Okay,
Okay. So 380 for violet, 750 for infrared.
can you repeat again?
So basically 750 is for infrared,
Yes.
while 380 is for violet light.
Yes, 380 is for the violet and 750 is for infrared. Okay. So basically, we can easily observe in simple words. We can say that we are only able to observe those seven colors that is or that are known as rainbow colors, right? Okay. Any confusion? Okay. So let's start with the new wave. The next one is ultraviolet. Okay, when we start moving towards the violet color in visible light, so after the violet color, we are having a ultraviolet rays, right? Because it is a greater than violet color, so that's why we use ultraviolet rays, right? So basically,
Yes.
what are the uses of the ultraviolet rays? Because this is very important type of ray, because in most of the MCQs they used to ask about UV rays. So the first one is, it is responsible for giving us a suntan, which is your body's way of protecting itself against ultraviolet, right? And there are some other uses. Let's suppose if we talk about any substance, when we expose their substance to ultraviolet, right? So they absorb it and re-emit it as a visible light, right? So actually, let's suppose if we just strikes the UV light over any substance, so that substance actually absorbs that UV light and then re-emit it, or re-emit that ultraviolet light in the form of visible light, right? So they will start like glowing, right? The simple example of that fluorescence, right? Those RGBs light, like those uh, glowing lamps are known as the example of ultraviolet rays, right? Because when ultraviolet rays starts to emit, and when they just strikes the substance, so it will re-emit that light, and that will be in the range of visible light. So we are able to observe that violet color, pink color, blue color, yellow color. So those RGB lights, or like glowing lights, are the application of ultraviolet rays, right? So in simple words, we can say that the process of fluorescence is the application of UV rays, right? So process of fluorescence. So these are these different applications, or these are the different daily life examples related to the UV rays. And further, if we talk about the another type of waves, so that is known as X-rays. And X-rays are the most common term that we use to observe in our daily life. So that is not like a new concept because we already know about the X-rays. So we use X-rays in the medical application or in the medical field. So actually we use X-rays in the medical field, and we know that when X-ray pass through the body, it can be easily pass through the tissues, cells, skin of the body, but they are not able to penetrate through the bones, right? So X-rays can easily pass through the skin, tissues, and muscles, but X-rays are not able to pass through the bones of the body, right? So these are some daily life few examples that are related to X-rays, because X-ray is a complete process. And the last one is the gamma rays. So if we talk about the gamma rays, so gamma rays has the greatest frequency or the greatest wavelength. If we talk about the gamma rays, so according to the timeline, so gamma rays has the greatest frequency, right? Because
Greatest
it is,
frequency, but the shortest wave.
yes, shortest wavelength. So this is the most important thing for gamma rays, because this is the special property of gamma rays among all those seven types of wave. So that's why we can say that gamma rays has the greatest frequency. And if we talk about the gamma rays, so basically, gamma rays are like the dangerous waves, because these types of waves are not like to be used in our daily life. So actually, it is used to kill cells, living tissues. These gamma rays or these laser treatments, you know that in the hospitals now with the advanced technology, now we have laser treatment, gamma rays treatment. So all these treatments can be made possible with the help of these gamma rays, because these are ultraviolet or gamma rays that can easily penetrate through the bodies, and they can easily kill the germs. They can easily just cut out the tissues of the body. So that's why in nowadays we are using these radioactive technologies or latest laser technology, right?
Yeah. Oh, they sound risky.
Yes.
Gamma ray sounds extremely risky to use, even if you know how to use it in daily life.
Yes, actually,
Still,
we are not using in daily life, because when we start studying the concept of the nuclear physics, so gamma rays is actually a type of radioactive ray. There are three different rays: alpha, beta, and gamma. So gamma is the most dangerous and with the most penetration power, right? So
yeah,
that's why, according to the environment of our human beings, so according to the health of our bodies and according to the structure and the whole formation of the body, so gamma is the most dangerous among all, because it can easily pass through the body. And you know that in the nuclear plants, those workers who works in the nuclear plants already have a few diseases, because they are continuously working in those radiations. And let's suppose if we take the example of X-rays, because gamma rays is dangerous, but if we talk about X-rays, so X-rays is like our daily life application. A thousand and millions of people daily took the X-rays, right? So that is the concept. But still, let's suppose if you have two or more than two X-rays to be done, so doctor advise you to only take maximum two X-rays per day, right? Because they know that if continuous X-rays are going to be passed through your body, so that will be difficult and very dangerous for you, right?
yeah,
So that's why X-ray is also a difficult one. It is also not like the easy one. Okay, so let's continue with the remaining part. So it is used to kill germs, cells, and tissues. And the use of gamma radiations are now very common in cancer treatment or cancer detection. So this is the one most important application in our daily life in the medical field, that we use gamma rays to just detect cancer and to treat the cancer patients, right? And we also use these gamma rays to sterilize food. So these are the journal overview of the concept of electromagnetic waves. Okay, these are 7 waves. We talk about some basic concepts related to those 7 waves, right? We talk about that which one has the greatest wavelength, which has one has the greatest frequency. So this is the concept, right? Any confusion till now?
No, sir.
Okay. And we also discuss why and how we use these waves. And there are other some multiple applications for X-rays and gamma rays, because X-rays and gamma rays are mostly used in the medical field in cancer treatment, to kill germs, to kill tissues like this. So ultraviolet and X-rays and gamma rays are most likely to be used in the medical field. Visible light is normally we use for the light purpose in our daily life. Infrared are actually emit out from the hot objects or when there is a high temperature. So infrared can also be used in remote controls, and microwaves are generally used for the satellite communication, and radio waves are used for long range communication, right? So these are the journal overview and the basic concepts of all type of forces, right?
Sir, I have a question.
Hmm.
When you say to kill tissues, what do you mean that? Like the tissues which are like infected or
Long range communication, radio waves.
you know, like for when you said used to kill tissues,
This one used to kill germs and tissues. Gamma rays.
yes, yes, the gamma rays. But
Okay.
the tissue part, like the
Yes.
infected ones or
Yes, the
the
infected one.
healthy ones?
Yes, the infected one. Let's
Oh,
suppose some patient have cancer or any type of disease that cannot be cured with the help of the medicine. So for a quick recovery, they use this treatment, because this is extremely high risk of operation also, because it may also damage your other tissues or cells of your body. So that is a risky one also. So but that was the last option for the doctor when nothing works for you. So then this will be the last option for the patient to go with this laser treatment or gamma rays treatment, right? Otherwise normally we are not using this in medical field, right?
but it's still an option, just the
Yes.
last thing.
Yes, the last thing, because you know that it is very dangerous, and it is not easy one for everybody or every person to just deal with this gamma radiations or X-rays on daily basis, right? Okay, any confusion?
No, sir.
Okay, okay. Now let's try to see some questions related to this chapter, because this is the basic thing from, or we can say that this is the whole conclusion of this chapter. There is nothing more special or nothing is new in this chapter. So let's try to figure out some questions from this chapter, and let's see how questions are designed from this chapter. This is for sound. Okay. Yes, this is electromagnetic spectrum. You can see that there are 26 question total. It means not much detailed questions included in your exams for last years. So let's see. Okay, so this is the start of the MCQs. Microwaves are used to transmit television signals to and from a satellite. Which statement about microwave is correct?
They have,
Okay, they mentioned the statement, right? We discussed that microwaves are used for satellite transmission, right?
yes,
So that is the already discussed thing that we already discussed. Now, which statement about microwave is correct, right? So the options are related to they have a longer wavelength than radio waves. If we compare the radio waves, let's suppose if we compare radio waves, so radio waves are on the left hand side. So it means that the wavelength of radio wave is greater than micro, right? So option A is not possible, right? And the second thing is they penetrate the atmosphere without significant loss of energy. Yes, this is possible because we discuss in the application of microwave. They can penetrate through the Earth's atmosphere. So B
yeah,
is might be
understand that.
possible. Yes. So let's see other options. They travel much faster. No, this is not possible because
No,
at the start of the chapter we discuss all waves starts to move with speed of light. So C is also not possible. And
I think B is possible.
they warm the satellite and stop it freezing. Or the B.
Yeah, I think B.
B is the right one because we discussed this because the main purpose of the microwave is to
Okay,
communicate, right?
satellite, like satellite
Yes.
communication.
With
Yeah.
satellite, yes, for communication. We are not using to maintain the satellite, right? So that's why option D is not possible. Only C is possible. Okay, in option B, sorry, question two, where are gamma rays used? So we discussed about gamma ray, the last one, the dangerous one, right? So these are the application. Now let's figure out from the given options. In fluorescence tubes, in killing cancerous cell, in prenatal scanning, in sunbeds,
Um, B.
killing cancerous cell, because we discussed that gamma rays are used to kill the cancerous cell or the tissues, right?
Yeah, it's like the last option in medical field.
Yes.
Exactly.
So this is the last application also. Okay, so the next one is which component of the electromagnetic spectrum is used for television transmission from satellite? Now you can see again they are asking about the same concept, but in different form, right?
Right.
So what will be your answer for question number three?
Which component of the
Okay, in question number one, we
wait,
already discussed. Yes.
um, microwaves?
Uh, just focus on this word satellite. So actually, which waves are used to connect with the satellites?
Oh,
Mi- Microwaves or
micro.
radio waves? Microwaves, right? So mostly they
Yeah,
ask about this satellite question in many years in different form. So answer will remain same microwaves, right?
right.
Now question four. So in option A, gamma rays have longer wavelength than ultraviolet wave. Is it possible? It is not possible because gamma rays have the greatest frequency, right? So it has the shortest wavelength. So option A is not possible. Infrared wave has a lower frequency than radio waves. Is it possible or not? If we talk about infrared and radio, so basically, infrared is on left hand side and radio wave is on extreme left. So it means the wavelength of radio wave is greater than ultraviolet rays, right? Sorry, infrared. So we can say that frequency. Okay, so sorry, they are asking about the frequency. So infrared has the greatest frequency as compared to radio. So frequency will be greater as compared to the radio waves, right? And then we
Yes,
have
sir.
microwaves have longer wavelength than visible light. Is it possible? Now microwave has longer wavelength. So microwave on the left hand side, okay. Then visible light. So it is also possible that microwave has greater wavelength than the visible light. And C is the right option because in option B,
Yeah.
infrared wave has lower frequency, but from the timeline, we can say that infrared has the greater frequency as compared to radio, but they are asking lower frequency. So this lower
Oh,
frequency is not possible, right? So it is like sometime confusing because we are solving for the first time. So you may take reference from the timeline because this is the initial. So it may be difficult to just quickly memorize all the sequence, right?
yeah.
Again, microwaves application. So what will be the application of microwaves?
Option D.
Satellite television, right? Question 6. Question 6 is which wave property has the same value for all X-rays traveling in air?
Hmm, I'm not sure.
Very simple, speed, right? Because all waves are
Oh,
moving
yes.
the same speed, right? Okay, now we have some different range for the reference. Question 7, there is a list of the table that contain main components of electromagnetic spectrum and their approximate frequency range, right? So this table shows you the frequency. So there are different frequencies. Now, which range of frequency can be used to detect cracks inside a block of metal? So actually, we need to use a very high frequency wave, right? That can easily pass through the cracks of a metal. Cracks of the metal means that can also be passed through our bones, right? So we need that type of frequency that can easily pass through the bones of the body and also through the cracks in a block of metal, right? So what will be that range of frequency?
Um, 10, 1018 squared to 1022.
Okay, this one, gamma.
Yeah.
Okay, first of all, we need to identify the wave. So we know that gamma is the ray because it can easily penetrate through the metal. So now we need to find out the related frequency in the options. So 1922, the number. So D will be the answer. right? Because it is between 18 and 22.
Yeah.
So this will be the possible range, right? Because we know need high frequency wave to pass through the metal. Question 8. So the radio wave has the speed of c. So this is the value of speed. A radio station transmits wave with a wavelength of lambda, right? And what is the frequency? Frequency, speed, and wavelength. So if you want to calculate the frequency, so what will be the formula to calculate frequency?
Option B.
We know the formula V equals to F lambda, right?
Yeah.
And F will be equal to V over lambda. And actually V is
Oh,
equals to C in this formula. So C over lambda.
oh,
So option A. Okay. Question number 9. Below are four statements about the uses of electromagnetic radiation. There are four statements. How many of these statements are correct? So you need to identify the correct statement. Gamma rays are used in medical treatment. Is it yes?
yeah.
So it is possible. It is right. Infrared waves are used in sunbeds. Infrared are used in remote controls, right? Not in sunbeds. So this is not correct. Microwaves are used in satellite television. It is also correct. X-rays are used in intruder alarms. So X-rays are not able to use in intruder alarms.
No.
So two
There's no.
statements are correct, right?
Right.
B is the right one. Now try question number 11. So red and violet are the colors at the end of the visible spectrum, right? Red on the one side, violet on the other side. How do the frequencies and the wavelength of these colors compare? So according to pattern, we know that infrared is on left hand side, ultraviolet
Wow.
is on right hand side. So
Yes.
infrared has the greater wavelength as compared to the violet color. Okay. So longer wavelength red and higher frequency violet. This one, right?
Right.
And you can see that all questions are 90% questions are actually related to the timeline. Okay. That sequence of the electromagnetic waves. So this is the most important thing. Okay.
All right.
Any confusion?
No, sir.